Several modules ago, we quantified compounds by calculating mass, moles, and number of atoms. Another way to quantify samples is to rank them using simple estimation. As long as we understand what chemical formulas tell us, we can develop a strategy to rank samples in mass, number of molecules, or number of atoms. We can do all this using round numbers without using a calculator. We recall that the mole is our standard or reference amount of any material. To rank samples in mass, the strategy will be to first find the moles of compound. Our sample of interest may be 1 mole, greater than 1 mole, or less than 1 mole. If it is greater or less, we will ask, by how much? Then we will use the molar mass of the compound to estimate the actual mass of our sample. For example, which has the greater mass, 1 mole of CH4 or 0.5 moles of H2S? The problem gives us the moles of each compound, so let's estimate the masses. CH4 has 1 carbon and 4 hydrogens, so the molar mass is 16 grams per mole. Since this sample is 1 mole, its mass is 16 grams. H2S has 2 hydrogens and 1 sulfur, so the molar mass is 34 grams per mole. Since this sample is half a mole, its mass is half of 34, or 17 grams. By simple estimation, we find the H2S sample has the greater mass. Ranking in mass required finding moles of each sample. When we rank samples in number, we're presented with 2 types of problems. If we are to rank samples in molecules, we need to know the moles of compound. Don't forget that the term molecule only applies to covalent compounds. We cannot ask about the number of molecules in an ionic compound. If we are to rank samples in the number of atoms present, then we need to know the moles of the elements, whether it be a single element inside a compound or the total number of atoms of all the elements present. As we noted before, this lends an added layer of complexity to the quantification of compounds. Let's start with a problem that asks us to rank samples in number of molecules. We compare 80 grams of Br2 to 20 grams of C2H6. Since we're ranking in molecules, we need to know moles of compound. With 2 bromines in the formula, Br2 has a molar mass of 160 grams per mole. This sample is half that much, or half a mole. We estimate it to contain 3 times 10 to the 23rd molecules. With 2 carbons and 6 hydrogens in the formula, C2H6 has a molar mass of 30 grams per mole. 20 is 2/3 of 30, so this sample is 2/3 of a mole. We estimate it to contain 4 times 10 to the 23rd molecules. The C2H6 sample contains more molecules. The previous question asked us to rank samples in molecules. Here is one that asks us to rank samples in atoms, which contains more hydrogen atoms, 18 grams of H2O or 15 grams of C2H6. Since we want to rank in hydrogen atoms, we need to find moles of hydrogen in each. Again, 2 hydrogens and 1 oxygen give a molar mass of 18 grams per mole. This sample is 1 mole of compound. But note that in the chemical formula there are 2 hydrogens in each molecule, or 2 moles of hydrogen in each mole of compound. Therefore, this sample contains 2 moles of hydrogen atoms. 2 carbons and 6 hydrogens give a molar mass of 30 grams per mole. This 15-gram sample is 1/2 a mole of compound. Note that in the chemical formula there are 6 hydrogen atoms in 1 molecule, or 6 moles of hydrogen in each mole of compound. This sample contains 1/2 of that, or 3 moles of hydrogen atoms. The C2H6 sample contains more hydrogen atoms. The next question asks which contains more total atoms, 34 grams of NH3 or 40 grams of C6H8. This is perhaps more of a challenge, but we're going to solve it in the same way. 1 nitrogen and 3 hydrogens lead to a molar mass of 17 grams per mole. This 34-gram sample then is 2 moles of compound. Notice the chemical formula says there's 1 nitrogen and 3 hydrogen atoms in one molecule. This adds to 4 total atoms per molecule, or 4 moles of atoms per mole of compound. This 2-mole sample then must contain 8 moles of atoms. 6 carbons and 8 hydrogens lead to a molar mass of 80 grams per mole for C6H8. This 40-gram sample is 1/2 of a mole of compound, but we need to know about atoms. The chemical formula tells us there are 6 carbon atoms and 8 hydrogen atoms in one molecule. This adds to 14 total atoms per molecule, or 14 moles of atoms per mole of compound. This half mole of sample then must contain 7 moles of atoms. Estimation tells us the NH3 sample contains more atoms. In summary, we have ranked samples in mass. The key was to find how many moles of each compound were present. We've also ranked by number of molecules. Again, we needed to know how many moles of compound were present. The last set of problems asked us to rank samples in number of atoms. There we had to find the number of moles of each element or elements present. We should associate molecules with the compound as a whole. We should associate atoms inside a molecule with the individual elements inside a compound.